Welcome everyone. My name is Kevin Burke and today I'm presenting with Colin Lawrence. We are both product engineers on the Collector development team, and today we're going to be discussing Collector for ArcGIS, high accuracy data collection. So a little bit about what we're going to be going over today. We're going to go through an introduction, kind of see how Collector is currently being used for field data collection with high accuracy receivers. We're going to discuss getting started and some considerations that should be made before starting a high accuracy data collection, or if you're already in one, some things that maybe you should be thinking about. Then we're going to run through setting up Collector for high accuracy, and then we're going to run through the field data collection process. Then we're going to discuss a little bit about using offsets to capture features and the current support that Collector has for laser rangefinders. And then we're also going to discuss some additional tools that can help with some analysis back in the office. So Collector for ArcGIS. Efficient data collection works anywhere, anytime. It works online and offline, depending on where you're at in collecting data and if you have internet connectivity or not. And obviously why we're discussing here today is high accuracy location capture. This is available on iOS, Android, and Windows. Workflows are very similar across all three platforms. Today we're going to be focusing on using iOS to demonstrate some of the functionality. But if you're using some of the other platforms, what we're going to be going over is very similar there as well. So how is it being used? So Collector can be used for collection and maintenance of asset data, also for capturing observations in the field, and performing field assessments such as inspections, which is a very common workflow, especially for different assets or different, different items you might be capturing in the field. So high accuracy GPS is very easy to use. The app is a very easy to use user interface to connect to the receivers and to give you the feedback that you need. It provides efficiency with processing on the fly, such as using real-time corrections or any type of correction services that you may be leveraging. And you can also be confident with using GPS metadata fields that are something we allow you to author with your data to capture certain information from the receiver that you can use for further analysis back in the office. Some of the common use cases, and a few that I've noted here that of actual Collector workflows being used right now, is in the bottom left, the Seattle Zoo Infrastructure Mapping Project. And this is kind of an interesting case because they're using an EOS Aero receiver with a laser rangefinder mounted to a pole to be able to capture assets at a safe distance outside of the animal enclosures. So it allows you to get that accuracy, but at the distance that is most applicable for that scenario. And then in the middle, the city of Centennial with CH2M is doing a public works asset data collection project with the Trimble Catalyst receiver. So they're getting high accuracy data collection in the field when they capture those different assets. And then on the bottom right, it's called Project Rock the Alps, and it uses a Leica GG04 receiver to map different rockfall locations for that location. So a lot of different interesting use cases, many more that are available with different types of receivers for different workflows. Another common use case for using Collector is to capture ground control points. And you can see in that middle picture, that's both Colin and I out in the Esri Redlands area in our parking lot. This is on our campus, and we're actually capturing ground control locations in the middle picture, in the left picture, where you can see the red X's. Those are all the ground control points that we've captured around this new building location that's currently being constructed. Above the ground, you can see the drone flight path in orange, and each of the blue dots is a photo that was captured from the drone as it was scanning back and forth across this area. Back in the office, the ground control points we captured were then leveraged to stitch these images together to create the orthomosaic that you see at the time. The building has since been much more constructed, but at the time, this was to get the initial lay of the land and get the ground control work done. So it's very useful for using high accuracy, such as RTK. In this case, we were using an N-trip connection to our local base station to get the centimeter level accuracy that we were using. So what's new in Collector? So for those of you who have used Collector Classic, which is now called, there's going to be a lot of enhancements that weren't able to support in that version that we can now leverage in the current version of Collector for ArcGIS. We've added support for grid-based transformations in the location profile, which includes side-loading grid files onto the device directly or downloading the grid files from ArcGIS online. We also added enhanced support for capturing elevations. Previously, we were only able to store X and Y, but in the current version of Collector for ArcGIS, we can support X, Y, and Z as well for those of you who are interested in capturing elevations with your positions as well. We also have support for capturing orthometric heights with various partner apps such as EOS Tools Pro, Leica Xeno Connect, Trimble Mobile Manager, etc. For many different receiver manufacturers that we partner with, a lot of their apps will allow you to download different geoid models for your area, and Collector can leverage the accuracy from those models. We also give you the ability to visualize your current GPS altitude within the GPS details. So GPS details, and you'll see more of this as we go later on in the presentation, is the ability to see the metadata coming live from the receiver. One of the values that we write is altitude. So you can see it as you're in the field, and you can know if that's an accurate location or not before you capture it. We also added improved UI, or user interface, for high accuracy workflows. So we've added improved user feedback when capturing outside of your required accuracy. So we give you visual indicators, such as we turn the text red if you're outside of your required accuracy versus blue when you're inside of accuracy. Just those visual cues. Again, a lot of this you'll see in the demos that we'll be showing you. It'll give you more context to a lot of what I'm showing you here. Lastly, we've let you visualize the point cloud when you're doing averaging. So if you're using an averaging workflow, we actually, if you zoom in close enough, depending on your accuracy, we'll give you the point cloud so you can easily see any outliers of your data and whether or not you need to more precisely capture that location. Maybe you need to enhance your positional accuracy through the correction service you're using, etc. So it gives you that ability, that visual feedback on the app as well. So getting started. So what are some considerations for high accuracy data collection? Number one, project accuracy requirements. This is what leads a lot of the different workflows. If your accuracy requirements change from project to project, you may approach it one way. If they're consistent for every project that you engage in, then you may approach it a different way with the receiver you use, the correction services that you have available to you to give you the level of accuracy to meet these requirements. The supported receivers, mostly for iOS. iOS receivers have to be supported for that platform, whereas Windows and Android aren't as strict in this respect. So you want to make sure that whatever receiver you plan to use is supported on that platform. Correction services. This is important for the area you're going to be capturing data in. If you're in an area of internet connectivity and you have access to a base station, you might utilize a direct IP connection or an N-trip connection to that base station over your cellular service. So you can get those corrections from that base station. However, if you're in an area with no connectivity or low connectivity and you need a reliable way of getting corrections, you may look at a subscription-based service such as PPP services like RTX or Atlas, to name a few, that you could leverage that are provided through the satellite rather than a cell connection to a base station. So just some things to think about with the correction service. GNSS metadata allows you to store, and I'll go through a lot of these more in the presentation, but for metadata, it allows you to store certain schema or write certain schema into your point feature layers to capture certain raw GNSS measurements from the receiver. And for the last two, they kind of go hand in hand. So your desired base map for collection and your datum transformation. The base map that you specify in your web map effectively sets the spatial reference for your web map, which it therefore can control the datum transformation you have to apply in Collector in order to not get any datum shift issues with your points. So as I mentioned before, we work with lots of different receivers, from consumer grade to survey grade receivers. It really just depends on your use case and application to determine what's the proper receiver, and in addition to that, what's the proper correction service available in your area. Using real-time differential corrections. Obviously, this improves accuracy from your receiver. Autonomous GPS, which is uncorrected locations, for any receiver is going to be undesirable for most projects. So you're going to need some other type of correction service to get you down to that level of accuracy that you require. As I briefly mentioned before, some of these require a subscription, like the PPP services, and a connection, such as an N-trip connection requires a cellular service connection. You can optionally use third-party apps to configure it. A lot of these manufacturers for these receivers give you the require you to configure these different types of connections through their app. And you also need to understand your map's projection and apply a location profile accordingly. When using a correction service, they're provided in a certain spatial reference. That information is important when populating your location profile for your datum transformation in Collector. So it's good to understand what that spatial reference is from that correction service. Using GNSS metadata. These are raw GNSS measurements from the GPS receiver. These are stored in up to 18 different metadata fields that you can write into your feature class and your feature, and likewise your feature service layers that you're going to be using to store this information from the receiver. This is very useful for performing further data analysis and for performing QA and QC on the field measurements back in the office. Again, you can store up to 18 fields worth of metadata. This applies for point features only. So lines and polygons don't store GPS metadata at this time. It only applies to points created with your GPS location. So if you were to place a point manually, none of this information would be written. And likewise, if you were to update a previously GPS point to a manual location, any previously captured GPS information, such as for these metadata fields, will be cleared out. And again, we'll go over more of this when we get into the demos in a bit. The fields can be created in several ways. So in ArcGIS Pro, there's a tool called Add GPS Metadata Fields. This is a tool you can run on your feature class before you publish, and it will add each of these fields to the feature class automatically. If you're using templates, feature layer templates through ArcGIS Online or ArcGIS Enterprise to publish your feature services from, there's a box you can check called Capture GPS Receiver Information. This will add the same metadata fields to that feature service when it's published. And lastly, you can programmatically, through using Python scripts that are available on our publicly available Git Collector Tools GitHub repo, you can add these fields programmatically using Python, depending on what your use case is. And last thing I want to point out is those last 4 fields I highlighted in yellow. Those apply only for averaging. So if you have averaging enabled, certain fields will be enabled and certain fields will be disabled as they don't have any relevance towards averaging. So it's really just the values that are required for that method of data collection. So datum transformation, this is a very important topic I wanted to kind of spend a few moments on. Datum transformations, there could be multiple different locations within a workflow if you can go from the geodatabase on the local machine to Collector in the field. There could be multiple locations where a datum transformation might be introduced, and I wanted to just highlight where those could be. For example, DT1 is datum transformation 1 is effectively the location profile that you will configure in Collector. This is the location profile specifies the transformation between your correction service and your web map, right? And so then we move over to datum transformation 2. This is when you've added a web layer or a feature service layer into a web map that's in a different spatial reference than what the base map is in. ArcGIS Online, likewise ArcGIS Enterprise, will apply datum transformation automatically for that scenario. And lastly, DT3, datum transformation 3, if your geodatabase feature classes are stored in a different spatial reference than how you published it, there could be a datum transformation there as well. So it's important to understand that each datum transformation has a corresponding level of accuracy associated with them. As you can see in the bottom right, the screenshot, this is from our geographic datum transformation tables that are available in our online documentation. I just took a little screenshot to highlight this fact. You can see in the middle there you have accuracy. This accuracy gets applied with every transformation. This, datum shift for this accuracy will get applied with every datum transformation that's used. So it's something to take into consideration when gauging the accuracy from your receiver versus the points you've collected on the map. If the accuracy from the receiver is centimeter level, but you're using a datum transformation that's sub-meter or sub-foot, then it's going to be shifted by that amount, and it won't really leverage the full accuracy from the receiver that you're getting. This isn't to say that you shouldn't use datum transformations. Sometimes they are necessary for the datums that need to be used. It's just if there's any area along this chain that could nullify the use of a transformation through using, say, your own custom base map that matches the spatial reference of all of your operational layers, which also matches the spatial reference of your correction service, say if they're all in GCS NAD 1983-2011 for the US, that would be a case where you wouldn't need to apply transformation or even a location profile in that case as well. So something to just be aware of where these datum transformations might be available. I also wanted to kind of highlight the DT2, datum transformation 2, from that model, the middle option. Again, this is the transformation between the spatial reference of your operational layers and the base map, essentially. Now, as I mentioned before, you could have a null datum transformation if every spatial reference for the layers and the base map match. If you're using an Esri base map that's in WGS 1984 Web Mercator Auxiliary Sphere, and you're using layers that are in NAD 83-2011, there's going to be a datum transformation between those layers in that map. ArcGIS Online will apply that in the map viewer, just like ArcGIS Enterprise will. And in that scenario, where you do have mismatched spatial references, which is the second bullet point, which ties in with the screenshot to the right, you can apply, before you publish, you can apply your own datum transformation in the data frame before you publish. In ArcGIS Pro, if you go into the data frame properties under transformation, you can set a transformation and that will be published with your service. It gives you more control over the method of the transformation that gets applied if you need to use one at publishing. So just something to also be aware of. Now we're going to go over, and I'm going to hand it over to Colin, who's actually going to now start getting into Collector and setting it up for the high accuracy data collection.
All right. Thank you, Kevin. So yeah, as you guys know, Kevin went over some of the basics of high accuracy workflows in Collector and went through some slides with you. And as he mentioned, I'm going to go ahead and show you what this actually looks like in Collector. So for the purposes of this demo, I'm going to be using an iPhone, so an iOS device, and connecting to a Trimble R2 receiver. So keep in mind that although this is a unique setup, other setups are going to follow very similar steps. So this should be helpful for everybody. So just to get started, the first thing you're always going to want to do for a Bluetooth receiver is go ahead and connect it via Bluetooth. So that I'm going to go into the settings in iOS and go into Bluetooth and wait for it to scan available devices. And there I see my R2 device, and I'm just going to connect to that. Once you have confirmation that it's connected, you can leave the settings and go back into Collector. And once in Collector, you'll see you're at your browse screen. We want to go straight into the settings in the top left-hand corner. So tapping that icon, you see the settings here. You see a couple different subheaders here. We're actually going to focus mostly on this location section here because that's where we're going to set up your location provider and your location profile. And the provider is going to be our Trimble R2. So I'm going to go ahead and go into that provider section now. And you'll see that it defaults to the integrated receiver, and the integrated receiver is what is built into your device. Keep in mind that this may not satisfy project requirements in regards to accuracy, as they may only get down to a couple meters at best for accuracy. So that's why we're going to go ahead and add our external receiver here. So you'll tap Add in the top right-hand corner, and this list should populate with any valid devices connected over Bluetooth, and you see our R2 here already. So we can go ahead and tap Add. And on the next screen, there's going to be a couple more options here. The first one is antenna height, and that is important for your receiver if you're taking vertical measurements in the field, or if you have your receiver attached to a range pole. For the purposes of our situation, we're going to set that at 2 meters. And below that, you see the real-time correction source, and Kevin discussed some of these options here. It's defaulted to SBAS for this particular receiver, and you may not see these options in Collector depending on the type and brand of receiver you are using. Since we are using a Trimble receiver, we do see these options built in within the app, but you may need to configure these in a third-party app for other situations. So I'll tap on the source and we'll see a couple options here. For our situation, we're going to be connecting over Ntrip. So I'm going to go ahead and tap Ntrip and then tap server to specify the URL. and then the port, and connect. And then you should get a another populated option called mount point, and that's just when you're going to specify the actual mount point that is relevant to this particular base station. And once you got that selected, you are ready to finish setting up that provider. So I'll tap done, and then you see that it has been added under location providers, and you just need to make sure you tap on it to switch over it to make sure that it's being utilized when you open up the map. So backing out into the settings, the next thing we're going to want to do, at least for our situation, is set up the location profile. So I'm going to go ahead and tap on that, and you'll see right now there's a default value for this one as well, and that one applies for when you're using an Esri base map, and also you don't have a correction source, or your receiver is collecting in the WGS 1984 datum, which means there's not a transformation needed between the Esri base maps, which are using Web Mercator, also the same datum. So for our situation, we're going to go ahead and add a location profile. So let me go ahead and tap add. And the first prompt you're going to get here is the first step, and that is the coordinate system used by your receiver. So in our case, it's going to be NAT83 2011. So you can search for that by name, or you can search for that by well-known ID if you know that. I'm going to go ahead and search by well-known ID, which is 6318. And you'll see that it filters out the results there and gets that exact coordinate system I'm looking for. I tap on that, it takes me to the second step, which is the coordinate system of your web map. And as I mentioned before, we're going to be using the Esri base maps. So this uses Web Mercator auxiliary sphere. So I'm going to type in the name this time. And you see it starts filtering down automatically. I don't need to type any more here. I'll just select one of these options here. And you see sometimes there might be duplicates listed here as they have been added. Different versions of them have been added at the same time or at later times, but for this purpose, they do the same thing. So I'm going to tap one of those. And you only see this next option if datum transformation is necessary based on the previous two selections. It's necessary in this case, so you can either zoom to your project location or tap your GPS icon to get there quicker if that's relevant, if you're at that exact location in the field where you want to use it. If not, you may want to pan to somewhere else where you're going to be working. For our case, we're going to do it right here and tap next. And then you get to the final transformation, the final screen, which is the datum transformations available. And just keep in mind that this is sorted in terms of the accuracy for the parameters, based on the parameters that you defined on the last screens. So generally, you might want to select the one on top, but just keep in mind that there are other options here that might be more relevant to your situation. Some other things that I wanted to point out before I move to the next step are that we have support for single and two-step transformations. You may see a plus sign here on some of these. And then also if I scroll down a little bit, you see a download icon. And those are for, excuse me, those are for grid-based transformations. So those are being downloaded and stored. Those are stored on ArcGIS Online, and you can download them to your device for use as well in Collector. So let me scroll back up. I'm going to go ahead and select that top transformation and tap done. And the last step here is to give the profile a name and give it something relevant to the location where you're going to be doing the data collection in. So if you have multiple profiles, you know which one you are selecting. For this, I'm going to name it Esri Base Station, so I remember that this is the setup. And then go ahead and tap Save. And one other thing I wanted to note is that we did add support for some additional coordinate systems at the 19.1 release. So now it should be up to par with what you see on the rest of the platform, including Pro. So that's also something to keep in mind. And then before I leave this screen here, you want to make sure that you set your base station as the currently used profile and not the default. And also you can use the information button to confirm the settings that you made before. So backing out there, you can see visual confirmation that I have my provider set up, I have my profile set up. Just one other thing that I wanted to point out before I hand this back over to Kevin and he moves on from there is the accuracy values under collection. So this can be important to consider, especially in relevant to this topic of high accuracy, because you want to set a good accuracy distance on your profile just to make sure that you're collecting good data. So if you set this too low, you might be collecting points. You might not be able to collect points at locations because your receiver can't get that level of accuracy. If you set it too high, you might run the risk of collecting data that falls outside of accuracy that you want. So if I set it at 30 feet and I don't realize that my receiver is getting accuracy at 10 feet and I really want it at 1 foot, then I might accidentally collect points at that accuracy level. So for the cases of this demo, I'm going to set this at 12 inches. So you can use feet or inches, or if you're using metric, you can also switch your units to use those as well. And the last thing that I wanted to point out here is the 95% confidence interval, which may be required by your organization. So that's off by default, but you can toggle it on. And if it is off, which it is by default, it uses the 68% root mean square. So I have my accuracy set up, provider and profile. I'm ready to go out into the field. I'm going to pass it back over to Kevin, who will recap this before we do our second demo.
Okay. Thank you, Colin. So just to kind of go over some of the things that Colin pointed out. So with the location provider, it is located directly within the app settings. There is support for integrated receivers, Bluetooth receivers, and serial receivers on Windows. Integrated receivers are just built into the device itself. This is where you connect to that named receiver, and also where you specify your antenna height for those who are interested in capturing elevations or orthometric heights. I also wanted to point out in the bottom right the list of iOS whitelisted providers. As I mentioned earlier on in the presentation about consideration for supported receivers, especially for iOS, there's a lot of supported receivers, a lot of which we've tested with, many different options that are available. From Trimble R1, R2, R10-2, you have EOS Aero receivers, you have Leica GG04 Plus, the Juniper Systems Geode, which was just recently released to support on iOS. A lot of different, Bad Elf, a lot of different receivers that are available that support different levels of accuracy for your requirements. Also in the location provider, as Colin demonstrated, this is where you configure your RTK corrections. Again, this is for Trimble only, but you can configure it directly within the app itself, which is accessible through the location provider details. The location profile. This is where you define your datum transformation between your correction service and your web map. So the input would be your GNSS coordinate system for your correction service. So in this case, it was NAD83 2011. And the coordinate system of the web map in this case was using an Esri base map, which is WGS 1984 Web Mercator Auxiliary Sphere. This does require datum transformation, which is sorted based on level of accuracy for that transformation. So it should be at the one at the top when you pick it. And then when you do pick it, or if you have to download it, if it's a grid-based transformation, once you're done with that, you want to provide a memorable name for that profile in case you may be working with multiple profiles, if you work with different correction services, or if you work in different areas, or different receivers, things like that, you may have more than one. So location accuracy and 95% confidence. So location accuracy is effectively your required accuracy. It's your threshold for your level of your acceptable amount of error for these measurements for that receiver. And it should be a fairly realistic number. It shouldn't be too ambitious for the receiver and the type of accuracy you can acquire with it, or it may hamper your ability to actually capture locations. Then again, if it's too high, it's not going to give you that level of QA, QC, if you will, for those measurements, because it's not going to alert you, if you will, if your receiver falls out of accuracy to a different fixed type. Say if it falls out of RTK fixed, falls back to SBAS or differential GPS, then your accuracy would reflect that, and if you have the required accuracy set up, it will alert you to that. 95% confidence interval, as Colin mentioned, it's off by default. If you toggle it on, if it's a requirement for your organizations, factors get applied to both the horizontal and vertical accuracies to report those values higher, but at a higher confidence interval, as opposed to the 68% RMS, which is what's standard. So just to be aware that this is where that setting is located if it's a requirement for you. Now we're going to pass it back over to Colin, who's actually going to go through the field data collection process and put that setup to use.
Thank you, Kevin. So basically, we're going to pick off basically where we left off on our last demo. And I'm going to demo some field collection workflows and with some data, hydrant data, valve data, water network data here on our Redlands campus. We're going to go ahead and play that video here. Picking up from our last demo here, I'm going to go ahead and make sure we have our setup as we set up before. So I'm going to switch back over to that R2, and you can just confirm the settings here if you need to. We don't need to make any changes yet. And then I'm going to jump right into the map, and I just want to show you a safeguard that we have put into Collector here. It's going to give me a warning that I have an incompatible location profile set up. And that means, oops, I forgot to set up that profile that I made in the last demo. I just need to go back to the settings and switch over to that. So there it was on the default. That's why I got the warning. If I set it back to the Esri base station profile that I had before, we will avoid that warning and be collecting the data as we would expect. So as I here in Redlands, I'm outside of our building here, just stepping away. The accuracy is not quite what I want here. So I'm going to talk through a couple things as I walk over to the hydrant that I want to collect. Basically, we're collecting some hydrant data here outside of our building here on the Esri campus. So you see the GPS banner there on the top of the screen here is displaying some red text. That means it's red because it's outside of that 12-inch requirement that I set up in the earlier demo. So it's warning me, hey, you're not within that accuracy that you're requiring. It'll allow you to collect points still, but only after you dismiss a warning. So I'm walking towards the hydrant that I want to collect. As you see me moving here, you're going to see that as the device warms up and as I get further away from the buildings and cover, that accuracy is going to improve. And once it gets under that requirement, there you go, it switches over to that blue text. You may see it bounce back and forth a little bit here, but that blue text is what you want to see. And I'm going to wait here a little bit as I get on the point, the hydrant that I want to collect, and that accuracy level moves down a little bit here. So give me a second, and then we're going to go ahead and collect a single point here to collect that hydrant. So for this demo, this is a single shot GPS point. And real quick here, I'm showing you the GPS details as well. So this is something that Kevin kind of went over a little bit briefly earlier, but this is stuff that you can quickly look at, what provider you have set up, the altitude, accuracy, the location profile down there at the bottom, your correction source, the end trip I set up before, and even the battery of your receiver if you're using a Trimble receiver. So this is something to quickly check on while you're in the field to make sure everything looks normal before you go ahead and collect your point. So once you've seen everything here, you can dismiss that, and then we're going to go ahead and do that single shot collection and collect at this hydrant that we're looking for. You can see my accuracy is at 1/2 inch. That's great. I'm going to zoom in a little bit just for reference, and then go ahead and start the collection. I'm collecting a hydrant in this case, so it's going to drop a point on my current location. You'll see the coordinates are populated there in the pop-up. You may need to fill out some additional fields here, so I'm going to go ahead and add the date, and then I'm going to also add my name because I'm the one inspecting this. And then for right now, that's really all I'm going to populate here. I'm ready to submit this point. And once this is submitted, I want to show you what happens within the pop-up as we're going to see that metadata, those metadata fields we discussed come into the pop-up. So if I expand this, you'll see some additional stuff that you didn't see in the editable pop-up. Those are that metadata fields. So I have my R2 receiver under the receiver name. I have some accuracy values. I have the lat long, the altitude, PDOP, HDOP, some other fields like that, and the fixed type as well, which is also very helpful. So this is good information to help you QA, QC while out in the field. And you see those averaging values aren't there. I'm going to demo when those averaging values show up later. And just to be thorough, I'm going to go ahead and add a picture of that hydrant here and then submit that. And once that's done, I'm going to go ahead and demo what we do to update an existing point. So the first thing that I'm going to show here is actually really nearby here. I'm going to zoom in. What looks like 1 point is actually 2. And this is a good way to show you functionality we have in Collector called Basemap Overzoom, which allows you to zoom past the lowest available scale level with the base map, so you can get in and look at those points up close. And for this case, since they're so close, I need to do that in order to click on the correct one. So as I walk over towards this point, you'll see that I might jump around a little bit as the receiver is trying to get an accurate fix since I'm carrying it. but I've approached the place where I want to update this point to. So I'm going to go ahead and tap on that point, tap edit. And then tap the GPS tool to zoom to my current location. I'm just going to zoom out a little bit just for reference for you guys. And then tap on that GPS icon again to make sure I'm locked in on my position. And then you're going to tap update point to change that location of the point. Once that's done, you can make any necessary changes within the pop-up, any attributes you need to update. Go ahead and do that at this time as well. Everything looks good here. I can go ahead and submit this. And you'll see for updating locations, as long as you're using your GPS location, the same principle applies with the metadata. So let's go take a quick look at those metadata fields. Looks good just as it did with the single shot point I added before. So we're good to move on to the next assignment. So the next one we're going to be doing is a little bit further away, so as I walk, I'll kind of explain the context of what we're going to be doing. I did say we're going to try one with averaging, so what I'm going to be doing is updating another hydrant location, this time using GPS averaging. So basically what GPS averaging is a setting where it allows you to drop multiple points at a location and average those points into a final location, to a final point. So just keep in mind that this process does help improve precision, but it does not help improve the accuracy of your receiver. So it can be a little bit misleading in the way that you think about it, but just keep that fact in mind. And this is something that does need to be configured within the settings. So when I do arrive to this point, we're going to want to jump out of the map briefly and into the settings to turn this on if you haven't already, and set the amount of points you want to average. So I've arrived at this next hydrant that I want to update, and before I tap and start updating, I do need to turn on those averaging, as I mentioned. So once I've got the receiver set up and where I want it to be, I'm going to jump out of the map. And back into the settings, you'll see GPS averaging under the collection header. It's off. Let's toggle it on. And once you toggle it on, you're going to see a secondary option to define how many points you want to average. The default is 10. I'm going to set this to a little bit higher just so I can demonstrate this better. 25 will work. Once that's all set up, I can back out of the profile, back out of the settings, and back into the map. Pick up where we left off. So as I said, I'm going to be updating a location here, so we do need to tap on that existing hydrant, and then we're going to start an edit session on it, just like we did at the last station. Once I tap edit, I'm going to make sure I'm on my location there, and then you can tap, you see the icon changes to start averaging instead of click point or update location. So once I start averaging, I'm going to zoom in to show you the point cloud, and you'll see these points are dropping here. You see in the progress in the status bar as it shows how many points have been dropped out of 25. It gives you that visual confirmation. And then once it finishes, you're going to see these dots disappear, this cloud disappear, and you're going to get a final location out of those that has been averaged. And there you go. You got that final point. I've updated the location using that averaged point. So I'm going to zoom out a little bit because we're way in here just to give context of where we are. And then again, if necessary, update any attributes. In this case, I'm good to go. We're going to go ahead and submit this. And then let's take a look once it's submitted at the difference in the metadata. You'll see right away some things are blank. And this is expected when you're using averaging because they don't really fit the use case of averaging. So then at the bottom, you see that those averaging fields are filled out. Among them is the accuracy as well as the amount of positions you used and the standard deviation value as well. And again, this process is really helpful to find outliers in your data. So we have one more point to visit here. It's a little bit further away as well. And to get to this one, I could tap on it and just navigate to there. But I'm going to actually use a barcode to search for this feature and in order to bring up the pop-up. So real quick, I'm going to close this out and I'll demonstrate that for you. So you tap on search and then you tap on that little barcode icon above the keyboard. And if you have a barcode handy, you'll scan that, pre-populated with the attributes that I defined before. And that matches the feature that I'm looking for, so I can tap on that. And then we're going to navigate there using the compass. So if you scroll down below the pop-up, you see some additional tools. I'm going to use the compass. And once I tap on that, it activates compass mode. And you'll see the visual confirmation there with the line between your current location and the feature you're navigating to. And also in the details panel, you'll see a heading, which it needs to be west in my case, and a distance to the feature, which is about 240 feet. So as I start walking towards that feature, you're going to see that information update on the fly. As I get closer, the values are going to go lower, obviously, and so on. So I'm going to fast forward this so you don't have to wait for me to walk all the way over to that point. And we've arrived very quickly. And the first thing I'm going to do is just update this point with some averaging real quick, just to make sure that those metadata there is metadata currently present on this feature, because what I'm going to demo next is what happens when you update a feature manually. So here we go. I have metadata that was relevant for averaging. So keep in mind there are some empty values here, but we're going to edit this again. And I'm going to move this location with the crosshairs manually away and use that target location, which means I'm moving that point manually, and submit it. And then let's take a look at what happened to the metadata. And you'll see that it's gone. So this is a good hint back in the field. If you see empty values when you are expecting to see them, you might want to ask your field crew, did they accidentally move the point manually or drop it manually? It's just a good way to verify that your workflow is completed in the way that you designed it to. And that's all we got for the field demo. I'm going to pass it back over to Kevin, and he's going to recap some things, and then we'll move on from there.
Okay, thank you, Colin. So just to recap some of the points that Colin demonstrated. So GPS details, very useful for troubleshooting, and also just to get that live feedback from the receiver itself. In order to capture a point, in addition to the accuracy, you may want to know how many satellites you have. You may want to know what obviously where your vertical accuracy is, your correction age, and such, or altitude. You might want to leverage that information to determine if the point you're going to be capturing is correct or not. We also support base map overzooming, very important for tightly clustered features. If they're all clustered within a few inches of each other, a few centimeters of each other, being able to zoom in past the scale range of the base map that you have set for that web map will allow you to see those clustered points more clearly and able to measure distances, and also to help with identifying the correct feature. GPS metadata fields, similar to GPS details, very important information, but it gets stored with your point features based on those well-known fields that you've added prior to capturing the points. Great for QA, QC back in the office. Like Colin said, if you are expecting to see metadata values and they're all empty, you might want to investigate to see if those points were captured manually instead of using the GPS, or if the values themselves are higher than what's expected, might prompt for a recapture for some of them. Averaging. A lot of organizations also have requirements to capture supporting averaging. So whether it's 5 points or 10 points or whatever the minimum amount of points you need to capture, you can set that through the app itself and see that real-time feedback as the averaging process is progressing, to see the point cloud and if there's any outliers, giving you further indicators if you need to recapture it, or it also gives you more insight into what the receiver might be doing at that location. Just to kind of point out the implications of using an incorrect location profile. This would obviously cause a datum shift scenario. But I wanted to highlight in this scenario, I'm using two different points. One of them is using the default location profile in WGS 1984 as opposed to the profile that Colin configured, which is in NAD 2011. So you can see that the shift of these two datums is the distance between WGS 1984 and NAD 1983-2011. So if you're suspecting that you may have a scenario where your profile is incorrect and your points are shifted, looking at all of your points collectively, everything should be shifted in the same direction by relatively the same amount. If all your features are in different locations as far as how off they are from the reference location, the actual true location, if you will, of where it should be, where you're expecting it to be, then it may be due to the accuracy of your receiver. And we might need to investigate more about what type of correction service was being used, what level of accuracy you were getting at each of these points, and things of that nature. It typically doesn't reflect a datum shift if they're in different locations and by different amounts. Now we're going to switch gears a bit and we're going to go into capturing features using offsets. So I want to kind of explain how we currently support using a laser rangefinder to capture these offsets and how you can leverage this type of functionality. It's very important for certain workflows to utilize offsets. For example, if the point you're trying to capture is right up against a structure or under a tree and you just can't get the level of accuracy that you require, you can set up your tripod or whatever type of setup you're using at a distance away from that location, and then using the laser rangefinder, you can then offset that point to that location, but getting the accuracy from an open sky view where you've originally captured your control point before you moved it over to that location. Or if it's in the middle of a busy intersection, say you're capturing manholes, and rather than having to divert traffic or put somebody in harm's way in the middle of the street, you can use laser rangefinders to offset that location to that manhole and get the same level of accuracy, but don't have to be physically at that location. So it's good for those locations. So getting started, the current support for using laser rangefinders and offsetting features is currently limited to using an EOS GNSS receiver. In this case, you see the configuration that we have on the right here is using a tripod with the EOS Aero Gold receiver mounted at the very top. In the middle of that setup, on the top, you can see we have a laser rangefinder, which is the mid-range of that setup. You'll see it's the TruePulse 200X. That is then connected into the angle encoder to give you your horizontal angles, all atop the tripod. The software that you would need to use for this workflow is Collector for ArcGIS, obviously, and then EOS Tools Pro, which is the app that EOS provides that allows us to kind of integrate together with this workflow. There are overall 3 different methods that you can leverage for doing your offset work. All of these methods are available through EOS Tools Pro. One of the first method is using standard laser offsets. This is where you would just utilize the rangefinder by itself with the application. No need for the tripod in most cases. You can probably just use it by yourself depending on the level of accuracy you're going for. The second method is using range backsight, which is actually the configuration that it's set up in the picture on the right, where that leverages multiple control points to get you the accuracy and get you to that location you need. The last one is range offset to capture, with using multiple different range poles in that case, or different. It captures the intersection of different control points, so it allows you to use a different method for capturing that offset, just different ways. One of the methods we're going to focus on, just kind of to highlight one of the methods, is the range backsight offset. This is what I refer to as the more equipment-intensive workflow of the 3 methods, where this requires the tripod, requires a GNSS receiver, the laser rangefinder, and the angle encoder. So in this particular scenario, we want to capture, as I mentioned before, a location that's in the middle of a busy intersection, say a manhole, right? How would you go about doing this method? The first step is you would need to capture your backsight point. So the tripod would be physically at this location. Then you would capture this backsight point. Then you would physically move the tripod over to your control point to capture that location. Then from the control point, you would turn the rangefinder and fire back at your backsight point to set your 0 angle. Then you would rotate the laser over to the target you're going to be firing at and where you want the point ultimately to be offset to, and that's going to give you your angle, your horizontal angle from your backside point to the target you're going to be shooting at. So I'm going to give you a quick video of how this is going to work. So in Collector, we will leverage EOS Tools Pro to handle the backside work, and then it will send us back the updated location. So right now what we're seeing here is in Collector, I'm going to start capturing my point just at the location that I'm at. Now I'm going to utilize the overflow menu and choose offset from location. That's going to then open up EOS Tools Pro with the range backside method. At this point, I'm going to start capturing my backside point using 5 averaged locations. I'm going to click next. Then I'm going to take you to the control point location, and I'm going to start capturing this location with 5 averaged locations. So I've already moved the tripod to this location. The next step, I've fired the rangefinder at the backside point, and that's going to populate with that information. Then I click next. Now I'm turning the rangefinder to the target that I'm firing at, and then I'm going to populate all the slope distance information, azimuth, and when I click next, you'll see that point has been offset to my target location in the bottom of the map. When I submit this, you'll see that there's a lot of metadata fields that are unique to this workflow provided through EOS Tools Pro. So you can see I got all of the metadata for each of the control points that I've captured, all of the horizontal distances, the angles that I've captured. Very useful information for this workflow that you want to store with that feature. So that's just kind of an overview of the offset workflow that you can currently do within Collector. Now, some additional tools to help you with certain workflows. One of them is Project Z. Some of you may be familiar with this tool already, especially those of you who are working with orthometric heights. As I mentioned earlier in the presentation, that we allow you to store the Z value from the GPS captured points. However, because we don't currently have support for vertical datum transformations, we're leveraging the geoid model of the receiver itself, which doesn't necessarily have the highest level of accuracy for your application. So what this tool allows you to do, it's a tool available in a toolbox that you can run through ArcGIS Pro, and this tool leverages the raw GNSS metadata fields, as you can see X, Y, and Z in the tool screenshot on the right. Those get populated when you add in your input feature layer. Then this leverages the vertical datum transformations, which you do need to install separately through ArcGIS Pro, and this will let you choose the vertical coordinate system that you want to output to. Say if it's NAVD88, then you could choose that output coordinate system. This will transform it vertically to give you a more accurate orthometric height and give you a different output layer that has the updated Z value on the geometry. And this tool, as I mentioned, is available through our public GitHub repository it's called Collector Tools. And you can search for that in your browser and it should find you this repository that you can download. So what's coming, right? So what's kind of looking forward on certain functionality? I mentioned during the Project Z conversation, vertical datum transformation, something we've been working towards for a while now that is coming very soon, hopefully within the next few months. So hopefully, that now you can actually capture your orthometric heights within the app itself. You may not need to necessarily leverage the Project Z tool as much for that workflow. We're also going to be adding support for new GNSS metadata fields, such as direction of travel, which is the bearing value coming back from the receiver itself, so you can see the direction you're actually going when you capture that feature. Your speed, how fast were you going when that point was captured? Compass reading. This is the location sensor directly within your device. So this isn't coming from the receiver. This is on your handheld device like your phone or your tablet. This is the orientation that you were facing when that was captured. Very helpful for capturing attachments. At that location, provided that your device is facing the same location that you captured the point at originally, could be leveraged in that scenario as well. Also the position source. There's different types of sources that a point can be captured with. It can be captured with the integrated receiver. It can be captured with an external Bluetooth receiver. It can also be captured with your a manual location, would be user-defined. So now you have a way to differentiate. When you look at a feature outside of whether or not metadata is populated, this value will let you know that that feature was captured user-defined, which is a manual location, versus using a GPS receiver. So very helpful for certain workflows. And for the Android release, it is coming very soon. We're hoping to release near the end of the month. So that will be released with much of the same GPS functionality that you just saw on iOS. For this initial release, however, it will not include support for certain areas, such as averaging and such as a 95% confidence interval, which will be followed up in later releases. So that's something to look forward to if you're working with the Android platform. Thank you very much, everyone.